Okay, hey everyone. Yeah, I don't know. Making an online class tutorial seems more awkward than the actual class. But hey, we gotta finish this, right? So yeah, let's get started. So first of all, the one thing I missed in the previous class was to show you how to write bash functions. So over here, as you can see, this is how you're going to actually make bash functions. So it's going to be same as any function, and you have to put a curly brace over here, and you can access the parameters using the $1 and 2, just like you have seen in the previous class. So if I want to run this, first I have to go to the directory, and over here you have to make sure that it has the executable permission, which is this X over here. So if I try to run it, let's see what happens. As you can see, it printed this. So yeah, this is all I had to cover from the bash functions, and honestly it's not going to be in the exam, so it's not something you have to worry about. So yeah, if you have any questions about it, you can just like ask me later on. Okay, so yeah, let's get started with the actual content of this class, which is the structures. So the idea of structure is basically like class in Java. Honestly, it's almost the same thing, but the difference is there is no public or private or anything like that. In C, it's basically everything is public. So if you have defined them like this, a global variable, then it is going to be you are going to be able to like access it from everywhere. So yeah, the basic difference between structure and class is in class everything is private by default, I think. Yeah, I think so. But in structure everything is public, and you cannot make them private unless you use some sort of like um, file scope or something like that, like make it static or something. But honestly I have never seen anyone do that. So yeah, it's usually declared as a global variable, like global declaration, but you can actually put it inside here. It's still going to work, but again, nobody does that. So yeah, so basically the declaration of a structure is like this. First you have to write structure, then the name of the structure. Inside there you put some elements, and remember, you are not supposed to write functions inside here. It might be similar to class, but it's not a class. Okay, so yeah, you do not write any sort of functions here. Later you will see how to put functions here, but that's for the later class. That's not a concern for now. So yeah, the first one is int x, the second one is int y. It's basically two elements for the structure location. And remember, when you are done writing a structure, make sure you have a semicolon at the end. That's very important. If you don't do that, it's going to give you a very weird error. Let's see what happens if we don't put it there. And while I'm running it, one thing I want to mention is like I usually use this run as my executable name, but this is not a convention, and this is not something that's true for everything. You can write it to anything you want. Some people in the exam actually used run as their executable for some reason. That was totally wrong. So please do not follow this example as something that's like universal or something like that. Okay. So yeah, as you can see, it says that expected semicolon identifier before the int main. Because we didn't put a semicolon over here, that's why this error happened. Okay, so whenever you are working with structure, make sure you have a semicolon at the end. So I put the semicolon here, and as you can see, it runs perfectly, right? And if I try to run it, it just prints the 10 and 20 that I put here. So we can see that the declaration is correct. Okay, so also whenever you are like declaring a variable of a certain structure, make sure that you write struct, location, and the variable name. Okay, so yeah, I know that's pretty cumbersome, and later you will know how else to do that, but for now this is something you have to follow. And if you want to access any of the like elements of a structure, you use dot and then the element name. In this case is a dot x, and in this case it's a dot y. So yeah, and again in the exam, many people, many, like 80% of the students actually forgot that there should be a return 0 at the end. So if your main is int main, it should have a return 0. If it's a void main like this, in that case you don't need this, but otherwise you will need that, and void main is not a good idea. Okay, so yeah, this is the basic of structures. Again, if you have any questions you can ask me later. Okay, so that's one way to write structures. There's another way, which is this. So what you can do is in the structure you give it some sort of name like location. This is a convention to start with a underscore. So it basically says that I am creating a structure but I still didn't decide what name it's going to be. In that case you just put a underscore at the end, at the beginning, sorry. Okay, and rest of the stuff is same as before, but then you do this type def struct underscore location, then location. Now you can just use this location as a type. For example, over here, if you look at the previous one, you see that the struct was here, but now you don't have to include the struct over here because you don't need that anymore. Okay, I hope that makes sense. Let's see if I try to run it, what happens. No compilation error, right? I don't have to put any struct before it, and if I run it, it runs. Again, this is the name of my executable. It doesn't have to be run all the time. I just prefer that name. Okay, so yeah, there is yet another way you can write your structure, which is like this. In this case, I am actually combining the type def and the structure together. So first, this part is same as before, and then I write this type def and location, name of the structure, at the end. Usually I prefer this one, but it's totally up to you which version you prefer. It doesn't matter which version you use, you are totally fine if you use any of the versions, but make sure you have a semicolon at the end. Okay, otherwise you're going to get weird errors. And honestly, the semicolon error in structure is kind of hard to find. Usually for I sometimes forget, and in that case I face that error, and usually I don't have any way to figure out why that happened. Okay, so yeah, again in this case you don't have to write the struct at the beginning, and everything is same as before. And if you want to see if there's any sort of error or not, there's no error, you can run it normally. Okay, so yeah, these are some ways to declare the structures. Again, it's totally up to you how you want to use it, but this is my preferred method because it gets everything done in one go instead of having two segments. So you pick your poison. Okay, so yeah, the next thing I'm going to cover is um, well, how to deal with structures and pointers. Okay, so one thing you have to understand that in case of structure, it's always called by value. It's never called by reference. Like everything else in C, even the structures are going to be called by value. So if you are using a function like over here, they are being called by value. Okay, so whatever changes you make to old or move, that's not going to persist in the main. If you want the changes to persist in the main, you have to use a pointer, which is over here. As you can see that this is the preferred version I use, like I said. So I have a function over here called init location. It's kind of like a constructor of sort, and to make sure that the changes I make to L persists, like over here, I am doing a call by reference. I'm basically sending the pointer of location A in this function. As you can see, it's a pointer, right? So there's two way you can access the elements of a pointer. One of them is you basically write it like this. You put a parenthesis around the pointer and then you put dot and x. As far as I know, this is not going to work, but let's see what happens. See, it's a pointer, so it says that I should be using a arrow sign. It's not going to work this way, so this is wrong, and do not try to do that. If you want to use your dereference, use this, or for structures pointer there is a special operator which is the arrow operator. It doesn't matter which one you use, you can either use this or this, it's totally up to you, but yeah, whichever you use, you know what you are doing. Okay, so yeah, you can use the pointer arrow. Yes, it's actually called pointer arrow, I guess. So yeah, you can use this operator to access the value of it. So remember, if you are dealing with a pointer of a structure, it's either going to be like this or this. Any of them are good enough, so it's totally up to you. So in when you, that's one way to deal with the pointers of structure. There is there any other way? No, not that I can think of. So yeah, the other one I'm going to show you is like this. In this case, see, I'm not doing any dynamic allocation. It's literally a simple value returning. Like for example, you do something like just forget this word. For example, sorry, sometimes we do something like this, right? Int a equal to 10 and return a. In this case, I'm not doing any sort of dynamic allocation, right? So even in case of structures, you can do the same, which we did over here. We want to return something called location, like the type location over here, and then I'm just like creating a static allocation. It's not dynamic, right? I'm not using any malloc or calloc or anything like that. And then I am changing the value, and then I'm just returning it. So whatever I'm returning, it has to be caught by something which is over here. So location C is going to be equal to the summation of A and B, and I'm just like printing it. So yeah, let's see if it actually works. As you can see, the value of A was 2 and 3, which I printed over here. The value of B was B, X and Y was 4 and 5, and their summation is 6 and 8, which makes sense, I hope. Again, so yeah, this is how you deal with the pointers, and this is how you just do static allocation and just return it, which is completely safe. You don't have to worry about auto duration, because this value is being held by this. So as long as C exists, you don't have to worry about it. But we will see when we need dynamic allocation for structures. So yeah, you can also create this is pretty much the same old code. All right, yeah, so one thing you can do is, and most people do, is write their structures inside a header file. Okay, so as you can see, this is struct function struct func.h, and I hope you remember this part. So if location h is not defined, only then do this part. If it's defined, which will be defined after this line, then do not do this part. So this part is not going to be compiled. So if you do multiple header file inclusion, this takes care of this part, and you are not going to have any sort of like duplicate declaration or something like that. So anyway, over here I am declaring the function. which I did over here at the top, but instead this time oops, I'm actually doing it inside a header file, and I'm writing the function over here, which is a very bad practice. You should be writing your functions in a .c file, but just for the sake of demonstrating, I'm showing it over here. Please do not follow my example. So anyway, this is pretty much the same as before, but over here I'm just including the header file so that I can access them over here, which works just fine. Another thing you can do with structures is you can have an element that is an array. In case of that, you have to make sure that this is static. um, Sorry, with static I mean this is a defined value. You cannot use any sort of variable over here. Like you cannot use something like and then write a over here. It's not going to work. So please do not do something like that. So anyway, um, so I think that's more or less the basic of structure. um, I don't know, you might have questions about it. And yeah, so yeah, that's more or less the basic of structure. Now I will show you something complicated about structures. It's the like advanced level, and this part is going to help you a lot with your upcoming assignment, because many of these are part of the assignment. So if you are paying attention over here, then the assignment becomes pretty trivial, honestly, because you can just like copy paste stuff from here. Okay, this video is going to be public, isn't it? Well, I don't care. Anyway, so yeah, as you can see in this array, okay, so we are going to use some sort of dynamic array. It's going to be something similar to Java one, but like we are going to implement it by ourselves. So first I'm going to have an array type, which is iArray, and inside there's going to be a pointer. This is going to be the array we are going to store all our data inside. This is the dimension of the array, so it can be like 10, then it's going to have 10 um, um, size of 10 basically. And over here, this is the usage. The usage is basically the index of the array. In this case, you can name it index if you want, but like to follow the slide, I'm just writing it usage. So at first we need to initialize the array. So usually in Java you have constructor, but we know that in C we do not have any sort of constructor, so we have to call this by ourselves. So over here I'm writing a function called array init, and inside there I'm going to send the array as a pointer and a size. We need to send it as a pointer because we need to change the values of it. So if we are using a function and a structure, we need to do a call by reference instead of a call by value. That's why we are sending a pointer. I hope that makes sense. So yeah, inside here, first we are doing a calloc, and it's going to be the size of the size we are sending as a parameter. I hope you remember the parameters of calloc. It's the size of the array and then size of each of the elements. In this case, it's going to be int32 as we have defined over here. So yeah, first we are making we are allocating size, we are allocating data, we are allocating memory for the data. I'm so sorry about this. So yeah, the first thing we have to do after we do a malloc or calloc is to check whether it worked or not. Sometimes it might fail. If you do not have enough memory location or enough heap size, it's going to fail. So you have to check for null. So that's what I'm doing over here, and then I'm setting the dimension to size and usage to 0 because index starts from 0, right? And then I'm returning true. It's just a error checking thingy. Usually if you're writing a constructor or something like that in C, you should have some sort of way to check whether the function worked or not. So in this case, I'm returning true if it works and returning false if it doesn't work. Okay, so that's for the initialization. Next we have the append. So if we want to add something to the array, we are going to use this function. So again, we are using call by reference because we need to change the element of the array, right? And we have the element, the one we want to put inside the array. So first of all, we are checking whether p is null, pa is null or not. It's a error checking because we have to check that whether the array we sent has any sort of memory location or not. If it doesn't and we still try to put something inside, it's going to turn into a segmentation fault. So yeah, that's why we are doing that. And then we are checking whether dimension is equal to usage or not. By doing this, we are checking whether the array is full or not. If it's full, we are just doing a false, like we're returning a false. It is a very bad way to do it because your array is like size of 10, but you are trying to put an 11th element. It's just going to fail and it's just going to return, and that value is going to be lost, right? So later we will see how to not do that and make a way to put element inside there even though it ran out of memory. Okay, so for now we are just checking whether or not it has enough memory or not, and then we are putting the element inside the location. So usage is basically the index, right? So in the data we are putting element inside the index number L, usage. I hope that makes sense. So anyway, then I'm just increasing the usage so that it points to the next index of the array called data, and then I'm returning true. So if it works, if we manage to append it, it's going to return true. Otherwise, it's going to return false. So like I said, sometimes you don't want to care about like how much memory you have, and you want to put as many elements as you want. So that's where the whole dynamic allocation comes in use, right? You can actually manipulate how much data you can actually put inside the array, and you can change the size of it. So for that we have a better implementation of iArray append, in which case when we see that we do not have enough space, which is over here, in that case we are doing a realloc, and we are increasing the size by, we are basically doubling the size of it. Okay, so before it had size of dimension, and now it's going to be the double of dimension over here, and we're doing a realloc, and afterwards we are doing this over here. Okay, I have the indentation all messed up, so it's going to be like this. Yeah, much better. So yeah, over here first I am reallocating the whole thing, and then I am pointing data to the temp. And remember, because of realloc, they were pointing to the hmm, hmm, okay, I don't know if I run Valgrind or something like that, it might say that I have a dangling pointer or something like that over here. Dangling pointer basically means the pointer that cannot be reached anymore. So that could be a possibility, but for now just focus on this. Like if you realloc, we're just like um, doing data equals temp, we could have, and I'm not sure how much useful that's going to be. We could have done something like this instead. And it should have been fine, but honestly I need to do more experiment on this. But for now I'm just following the slide, like the code in the slide. So this is what was written. So in this case I'm sorry, I'm a terrible teacher. So yeah, in this case I'm just like checking whether or not Oh, I'm not checking anything. I'm just like making data equal to 10, and then increasing the size of the dimension, right? And then putting the element in the usage and increasing the usage. So this part is just like before, but over here we are actually increasing the size. So this part is going to help you a lot with your string assignment. So make sure you understand this part. If you don't understand what's happening over here, you can ask me in my office hour. Okay. So yeah, so this is a better implementation of IRA append because it makes sure that if you don't have enough um, memory for your element to be put into, you have more place now, right? Like by doing the realloc, you have more memory location. So yeah, now the last one. Okay, so in C there is no easy way to copy stuff. So usually it's something like if you write something a equal to b, it just um, copies the value. Yes. Hmm. But like in case of structure, the array is going to be shared, right? So if you have something like um, location, sorry, I array a and I array b, and you write something like um, you write something like this. So in this case, what's going to happen is A and D are going to share the same data. So whatever changes you make to A is going to be changed into D as well. I think I have to test that. Yeah, I'll test it at the end of this video. But anyway, for now, we are going to create a actual copy array. So we're going to write a, what is it called? So usually if you write something like a equal to d, it's called a shallow copy. But what we want to do is not a shallow copy, but copying the whole thing. In that case, we are going to write a function that copies one array completely and puts it into another array. Again, this is also going to be part of the assignment. So if you see this, you can just like copy paste it in the assignment and it's going to work. So yeah, at first I am sending the array as a pointer, and then I am creating a new array over here, which is, sorry, not a new array, but a I array. And over here we are using calloc, and it's going to be one element. So we're just putting one over here and checking whether it's null or not. Then we are allocating memory location for pcopies data, because pcopy is a type of I array, right? So pcopy is basically like this. So it also has a data. If you want to use this, you need to do some sort of calloc like you did over here. So even in this case, you have to do that. Afterwards, you are going to copy everything from one of them to the another. Oh, and one thing, if the data one fails, you also have to free pcopy. If you don't do that, it's going to exit the program just fine, but like it's going to have a dangling pointer or something like memory leak. Basically, there's going to be a memory leak if you don't free pcopy over here. So afterwards, I'm doing a one by one copy over here. So in the slide, if you check, you will see that they used mem copy, but I tried mem copy and for some reason it's not working. It's not copying the rest of the stuff. Why it's not working, I cannot answer that. Honestly, I have no idea why that's not working. So whenever you are copying one array to another, just do something like this. I know that's a very bad way to do it, but one of the students in the previous semester also faced the same problem, and I told them to like copy it one by one, and it worked. So when you're doing the assignment, you face this, try to do this instead of mem copy. Mem copy might work, but why it doesn't work time to time, I have no idea. Like in this case, for I actually tried to do mem copy and it wasn't copying the rest of the stuff. So that's something you should um, follow, I guess. So at the end, I'm just like putting the dimension and usage to its the same as the PA over here. So I made a full copy of the PA, and I'm just returning the P copy because it has every element same as PA at this point. So over here, I'm just like doing some sort of testing. So first I'm creating a I array A, and then I am appending, I am giving it the size of 1 so that I can actually test whether or not it actually managed to, whether or not it manages to append stuff, right? So over here, I'm putting an element 1, and then, oh, another thing I missed. I wrote a print function for the array. So it takes I array as a parameter and just prints till the usage. It's a pretty straightforward print statement. You can use it while you are testing for the assignment. So anyway, um, so I'm printing over here. Let's try running this. I think it's pretty self-explanatory. Let's try running it and see what happens. So what happened over here is, first I am initializing with the size of 1. Then I'm appending an element over here. And then I'm trying to print it. And it prints this. And then I am doing a better append. If I did a normal one, this wouldn't be added, because if you can remember from here, it just checks whether or not it's full or not. If it's full, then it's just going to return false. But because I used a better IRA append, it works. Let's see what happens if I don't use it. Remember this output, okay? Especially this one. With a side-by-side comparison, you can see that over here it managed to append something, and over here it didn't append that. That's because we didn't use the better append. So I'm going to keep it here. So over here, I'm also creating a B, and it's going to be a copy of A. And as you can remember, I had to send a pointer of it over here, right? So yeah, as you can see, I sent a pointer over here, right? So I also have to send a pointer, but remember, B itself is a pointer. So when I'm trying to print it, I have to send a dereferenced version of it, because it takes in a normal I array and not a pointer of a I array. So in this case, I'm dereferencing it when I'm sending it, and then I'm putting something inside A, and I'm also putting something inside B. Another thing to notice over here is for better I array append. As you can see over here, it's supposed to take in pointers. But look at the declaration of I array. It was a static declaration. So in this case, I have to send its pointer. But B itself was, okay, I'm going to put it enter over here. So B itself was created as a pointer. So over here, I'm just sending the pointer itself. And when I am trying to print them after appending, I can see that, what can I see? That it appended 3 at the end, but this one appended 4, right? Another thing I wanted to test is what happens if I do a shallow copy. So I am creating a new array called D, and I am assigning A to it. So let's see what happens. If I add something to A, does that change go to D as well? First of all, I'm just going to print D, and let's see what happens. D printed the same thing, right? Now I'm going to append something to A. Let's see what happens to D. Does it carry over or it stays the same? Hmm, it stayed the same. And if I try to print A itself, what happens? So, well, that was useless. I don't know why any of those was in the slide. If you can just like copy like this, like literally, they are completely different version of each other right now. So honestly, I don't know. It seems like a waste of time. Yeah. But anyway, I will try to give you a better explanation of it later on. But I hope you understand structure at this point. Also, I know this is literally the first online tutorial video. Yeah, it's literally an online tutorial video at this point. So yeah, if you have any other suggestion of how we can do this class, like do you need extra office hour or something like that to understand these concepts or not, please let us know. Okay, we are still trying to figure out what we are going to do with the whole online platform thing. So for now, I hope that was helpful, and please ask me if you have any question, and please make use of the piazza. Okay, well, I'll see you in the next class, or not see you, I don't know.